Okay, so finally, let's take a look at how to do data partitioning with R. So we are finally getting down to some coding here. So in order to do this, you can follow along the data actually. You can read the data from this file called partitionexample.csv. It's available on Blackboard. I've posted it. Right, so we read that into a data frame called dat. Okay, now this data set partitionexample.csv has a column called status, okay, which indicates whether a person is a buyer or non-buyer. So all I'm saying is table dat $status, and that tells me that of the 30 rows in this data set, 10 of the rows are buyers, 20 of the rows are non-buyers. In other words, there are twice as many non-buyers as there are buyers. Okay, now the reason I'm showing you this is that we are going to look at one way by which you can do the partitioning, and you'll see that there are some shortcomings with that. Okay, so now what I'm going to do is to partition this into training and test. Okay, and I'm calling this as simplistic partitioning because this is not what we'll be using. Forget this line for the time being, set.cd, ignore this completely for the time being. I'll come back to this later. And I say rows is sample 1:30, 21 replace equals false. Okay, so what I'm saying is I'm using this function called sample, which is inbuilt into R. You don't have to load any special packages for this. So I'm saying 1:30. If you remember, 1:30 is nothing but a vector consisting of 1, 2, 3, 4, 5 up to 30. I'm saying take that vector, and from that vector randomly select 21 elements. This is how the sample function works. Don't worry about memorizing this because we will never use this in the future. And then I'm saying replace equals false. In other words, once you have selected a value, don't put it back in. Okay, take it out, it's gone. You can't reselect a value, right? Obviously, you want to randomly select 21 elements from 1 to 30. There's no point in selecting 5 3 times. Once 5 is selected, that's it, it's gone. So I'm saying rows equals sample 1:30, etc., because there are 30 rows in our data set. So if I now do rows, it shows me that these are the 21 rows that it selected. Row number 26, meaning number 26, number 20, number 23, etc. Notice that all of these numbers are between 1 and 30 because it selected 21 numbers from that set of 1 to 30. Okay, now let's take the status of the elements from our original data frame, which is the this data, dat. From dat, let's look at the status of the selected rows, meaning these are the row numbers that were selected: row number 26, row number 20, row number 23, etc., and row number 30. Right? So now let's take a look at, for each of those rows, whether the corresponding element is a buyer or non-buyer. Okay, so here you've got the first 3 are buyers. In other words, row 26, row 20, row 23 are all buyers. Row 6 happens to be a non-buyer, etc. Okay, now let's see how many buyers and non-buyers were selected. So I'm saying table dat $status of rows. Okay, so I'm taking the buyer non-buyer, that is the status, and I'm generating it. It turns out that of the 21 we selected, 9 were buyers and 12 were non-buyers. Okay, now is this a representative sample of the original data? In the original data, remember, there were 10 buyers and 20 non-buyers. There were twice as many non-buyers as buyers. But in our sample that we generated, right, there are 9 buyers and 12 non-buyers, right? Ideally, the 21 sample should also have twice the number of non-buyers as buyers. But that didn't happen in our random sampling. That did not happen. Okay, so this is not a desirable state of affairs, because what we really want is the rows that we select for the training partition should be reflective of the overall distribution as well. If it's not, then that's not a great idea. Okay, so of the 10 buyers, 9 of them ended up in the training partition, which is not a great idea. Okay, so we will not use this approach for generating our partitions. Instead, we'll use a different approach. Okay, so in order to do that, you have to install a package called caret. Okay, so do install.packages caret, and of course this is a comment, you shouldn't use this. Install.packages caret. Okay, this will take a while to install. Unfortunately, we are going to install a fairly large package, but we'll be using only one function from that package. Once you install this package, load the package by doing library caret set.seed. Again, for the time being, ignore this altogether. We'll come back to this separately. Instead of using the sample function, I'm using this function called create data partition. This is a function in this package called caret. So I'm saying SAM is create data partition dat dollar status, right? In other words, we are saying, look, I'm interested in this column called status, right? And I want the training partition to reflect the proportion of the values of status in the original data. In other words, if I had 10 buyers and 20 non-buyers, I want twice as many non-buyers as buyers. Then when you generate the training partition and the test partition, make sure that in both of those also there are twice as many non-buyers as buyers. Don't put most of the buyers in one or the other partition. Evenly divide it across the two partitions. Okay, and we want the division to be based on this column. So that is why we are saying create that dollar status. That's because status is our target attribute, because we are going to be building a model, let's say, to predict whether a person is a buyer or non-buyer. So that's what we want to do. P equals 0.7, which means what we are saying here is I want approximately 70% of the rows to be selected. Right? Earlier we said out of 30, give me 21. That was also 70%. But when you use create data partition, you indicate P equals, right? And then list equals false. Just for what, don't worry about it. Just take it as it is. Okay, just say list equals false. Don't have to understand it for now. Later in the course, we'll get into why that is the case. Okay, so now SAM is nothing but a bunch of row numbers. Okay, so this time I'm going to look at table dat dollar status SAM, and notice that there are 7 buyers, 14 non-buyers out of the 21, because 21 is what we got, 0.7. Okay, so the non-buyers are still twice the buyers, which is good. This is better than our earlier approach. That is because we use the create data partition function, and that takes care of this requirement. So that's a very important thing. Now let's look at actually how we are going to use all of this to do data partitioning. Okay, so I'm using the file bostonhousing.csv, and we say read.csv. We put it into a variable called bh. Okay, and then again I'm loading the caret library. You don't need to because you've just loaded it in the previous slide. Forget about set.z for now. Okay, I'm just saying set.z 2015. Now you may say, well, earlier you were saying 9999. Why are you doing 2015? Actually, it doesn't matter, but we'll see why I'm doing that. And here I'm saying create data partition bh $medv. That is because this is our target attribute. In this particular data set, let's assume that this is our target attribute. Okay, and again we want to do 70%. There's nothing hard and fast about saying 70%, but that's just common. You can say 65%, 50% if you like, if you have enough data. Doesn't matter, but commonly we do 70-30. Okay, and once again we are supplying the target attribute. Okay, and in this particular data set, our target attribute usually is MEDV. Okay, and list equals false. So now sample is a variable that contains approximately the indexes, the row numbers of 70% of the selected rows from BH. Okay, now since you already know how you can use this in R, right, you can say train is BH square bracket sample comma. Okay, now in case you forgot how this works, I've posted a book on Blackboard. Okay, take a look at certain labs. I'll put all of this on Blackboard, so just work through them to refamiliarize yourself with R, in case you've forgotten all of this stuff, right? So sample is nothing but a vector consisting of selected row numbers. So all we are saying is from the BH data frame, take all of those rows and all the columns, right? Take only the rows which are in this vector sample, but take all columns because I have not mentioned any columns. So then that will become the training partition. The test partition is everything else, right? So you got this neat trick in R where you can say minus. So everything else is in the test partition, right? Now you can look at how many rows are there in BH. Okay, number of rows in training, number of rows in test, number of rows in training plus number of rows in test. You will find that that's the same as n row BH, right? So 356, 150, 506 is the total number of rows in the BH data frame. That has got divided into 356 in training, 150 in test. Okay, now sometimes when you use create data partition, you're saying p equals 0.7. Now you might find that the size of the training partition is not exactly 70%. It's a little approximate, doesn't matter. You don't have to worry about the fact that it is slightly different from 70%. Okay, finally, let's take a look at what is this set.seed thing. What's going on with that? Okay, let's take a look at that. Why should you be using set.seed? Okay, strictly speaking, it's not needed, but we'll be using it quite often for a specific purpose. Okay, now let's do this. I'm going back to our original sample stuff. Sample 1 to 30, 21 replace equals false. In other words, from the vector 1 containing the numbers 1 to 30, select 21 numbers randomly. Okay, so now if you print rows, these are the random 21 random numbers it selected between 1 and 30. Now let's do the same thing again. Well, it came out with a different set of 21 numbers, right? Of course, we said select 21 numbers randomly from a vector consisting of 1, 2, 3 up to 30. First time it came up with this. Next time it came up with this. This is different. That's what you expect because you said select randomly. Okay. Now this is fine, except that sometimes when you want your work to be replicated, in other words, you do something and I want to reproduce your results. Okay. In that case, this approach will not work, right? Because I will not be able to replicate what you did because my random numbers are going to be different than your random numbers. Okay. So the set.seed comes into play only in situations where you want the random numbers to be replicated exactly. In other words, you do it, you get one result. I do it, I should get the same results that you got. If we want that, then both of us should set the random number seed to the same thing, right? Of course, you're saying, well, we are not going to use sample, we are going to use create data partition. Well, internally, create data partition also uses random number generation, just like sample does, okay? So obviously, if you want to replicate, then you should use the same random number. Okay, now let's do the same thing that's going on here, but this time we'll do a set.seed. Okay, so let's say set.seed 1, 2, 2, 4. Now the point is, it doesn't matter what number you put here, right? Of course, it matters in the sense that somebody who wants to replicate your results should use the same number. If you used 1, 2, 2, 4, they should also use 1, 2, 2, 4. Then the results will be exactly the same. If you use 1, 2, 2, 4 and they used something else, 1, 1, 5, 6, 3 or 1, then their random numbers will be different from yours. But if they also use the same random number, then the results will be exactly the same. Okay, so you did 1, 2, 2, 4 and then you did the whole thing. You got the rows 4, 19, 18, 17. You repeat the same thing once again and you get the same random number. See 4, 19, 18, 17, 23, exactly the same set of numbers. Okay, so even though random sampling was going on here and here, but because the random numbers that got generated were exactly the same, you're able to replicate it, right? So you will use set.seed only if you want to replicate your results. Now in this course, you will use set.seed quite regularly. Reason being that you will want to make sure that your results match the results that I show. Okay, so just for that purpose. If you want somebody to be able to verify your results, then again you should use set.seed so that if somebody checks your calculations, they want to make sure you did everything right. then they should be able to replicate it. So set.seed is required. It's only for that purpose. Otherwise, it's not strictly required. So in this case, notice that since both these runs use the same random number, this should be 1224, not 1234. Okay, should be the same random number. Sorry, my mistake. Okay, so long as you use the same random number, then you will get the same results. Okay, so this is the reason you would use set.seed. That's it.